Okay, Assalamualaikum warahmatullahi wabarakatuh. Uh, we are from group assigned the project 1A compressor tank. Okay. The executive summary for this project is inspection for decommissioned steel air compressor tank. Okay. This tank service lifespan is about 10 to 15 years. Okay. Were previously used to be um, a air compressor for laboratory. Okay. The objective for this project is to assess structural integrity, recommend repair, and continue use or scrapping. Where we do where we use to inspect the tank for decide if the tank is can be used again or need to be scrapped. Okay. The timeline of project we use is 5 day 5 week project. Okay. And clean surfaces. Okay. The NDT method we use is visual testing, where we inspect the external defect mapping. Okay. Next, ultrasonic testing, where we measure the material loss inside. Next, the dye penetrant, where we check the weld joint integrity. Okay. Critical findings and verdict. Widespread non-compliance that we use is from API 5510 or SME section 8. Okay. Severe thinning. The absolute minimum remaining wall thickness record was 5.30 mm, where it located at grade 5, representing an alarming reduction from 8 nominal design thickness. Okay, web flaws, the penetrant testing confirmed surface breaking defects, including a linear crack like indication along the primary longitudinal symptom. Final verdict, permanent decommission and scrap. We decide that this asset need to be scrapped because they fail to meet the criteria.
Assalamualaikum and hi to Dr. Intan Shahida. I am Nurliana Afifa binti Ahmad Rizwan. So now I would like to present about Project 1A, a compressor tank. So the first one, we will analyze the job hazard. There were 4 steps of job step. The first one is a vessel setup. The hazard is residual pressure and kinetic energy. The risk is height. And the control is lockout or tagout. LOTO, verify depressurization and open drains. Next is surface prep. The hazard is dust, debris, and noise, and the risk is medium, and the control is goggles and 95 mask and ear protection. The third one is chemical PT. The hazard is VOC inhalation and skin irritation. The risk is medium, and the control is ventilation, nitrile glove, and safety glasses. And the last one is UT testing. The hazard is slip-on gel and economics, and the risk is low, and control is clean surface, wipe couplet immediately. Then the pre-inspection surface prep. So the first step is depressurization. It's isolated from a pneumatic line with lockout and pressure vented to 0 bar. Second, drainage and ventilation. The drain valve open to sludge and moisture remove, then nozzle left open for natural ventilation. And the last one is surface cleaning. We using the wire brushing and grit paper use, and then rust paint and loose coating strip. Then we will going through to NDT method selection. The first one is visual testing VT. It is baseline method and rapid mapping of dent, gouge and rust. Next is ultrasonic thickness UT. The external only measurement, no internal access needed. Then accurate wall thickness loss detection, and standard is API 510 ASME VARTS 0.5. And the last one is dye penetrant PT. It focus on weld joint, detect crack, porosity, function detects, and standard is ASTM E165 ASME VARTS 0.6.
Hello everyone, my name is Najus Itten, and I'm going to present about the next slide, that is about the UT and PT work instructions. This slide covers our testing instruction for UT and PT. For ultrasonic testing, on the left, we use a probe to send a high frequency sound wave into the metal. The formula is actually thickness to volume times thickness divided by 2. Calculate the wall thickness based on how long the sound takes to reflect back. We tested it using 100 millimeters by 100 millimeters grid, focusing on rusted areas. After calibrating with the steel block, we clean the surface and apply to coat the gel. That is the grease oil we use. UT is great for finding internal fitting and deep fitting, but through the surface or heavy corrosion, it can scatter the sound and cause a false reading. For penetration testing, on the right, the principle is capillary actions, where liquid and dye seeps into the surface cracks. We focus on the T-joint well, nozzle fillet, and the dented zones. The steps are very simple. Firstly, we clean the surface, apply the red dye for around 10 to 15 minutes dwell time, wipe the excess, and apply the white developer. This lets us easily to see the surface cracks, porosity, and well infiltrators. The main limit of the PT is that it cannot detect any substance or hidden defect. Okay, now for the next slide, that is the visual inspection findings. Next, here are our visual inspection findings. First, the exterior condition we found are heavily rusted scalings on the lower or third of the shell. This was caused by water pooling around the base and weather exposure. Secondly, we found a mechanical dent measured around 80 millimeters thick and by 50 millimeters, and the depth is around 6 millimeters deep, right in the center of the main panel. Unfortunately, the tank supposed to support shows no signs of bending or buckling, so the structure remains stable. Finally, here are the actual result of our penetration testing. In the left photo of the main butt joint, the white developer reveals a clear, continuous red lines. This indicates a surface crack right of the weld toe, which is a major safety risk for under pressure. In the right photo of the nozzle fillet well, the red dye highlight a smaller issues, specifically cluster porosity and minor fusion flaws. Whilst the flaws are small, the cracks can on the main well seam is a high priority that requires intermediate actions. That's all for me. Give the presentation to our friends.
Now we are into our thickness degradation process. Ultrasonic thickness mapping, yeah, deeply concerning. out of the 25 grid inspection points evaluated across the tank, a staggering 23 points failed to minimum safety thickness threshold 6.5 millimeter mandated by the API 510 section 8. While minimum design thickness of the shell is 8 millimeter, several internal and pitting corrosion have dramatic material loss. Absolute remaining wall thickness was recorded at 5, measure just 5.3 millimeter. This presented a critical reduction in vessel capacity. Concentrate primarily across the lower shell and bottom where moisture and standing water naturally. Now going to our discussion. When we correlate the using with our another destructive testing, the mechanism of degradation become visual testing confirmed heavy rush on the lower third of external due to a long-term climate exposure. Most critical, our dye penetration test discovered a major structural inflow with the weldment. The PT inspection revealed a surface breaking defect on both the butt and fin. Most alarming is the 5 millimeter linear crack line section running along the toe of the primary sentinel weld seam. This crack acts as a severe stress saturator combined with the excessive internal wall thinning we just discussed. The vessel's ability to withstand the cyclical pressure is a fundamental compromise. Now, bring to our final conclusion and engineering recommendation. Based on our safety criteria of the API 10, this pressure tank is completely unfit to continue the rate operating pressure of bar. Running this under current condition pose a many catastrophic risks and problematic. But therefore, we propose two actionable pathways. Primary recommendation is ultimately scrap verdict. Give that the fitness was falling well allowable limit and critical scrap disease on the primary living well. Structural remediation is non-economical reliable. The that should be mediated recommendation and scrapped. Another alternative composition can only be considered asset must be reused. This would be require a permanently degraded vessel to a maximum operating below 4 bar or completely rewelded the structure crack and forcing the vessel to clear a formal hydrostatic testing before thank you and